started Richa Industries after passing out my MTech from IT Delhi in 91 as a textile company. In 2008, we came with a diversified PB sector. Till now, we have completed almost like 600 projects, 600 buildings, mainly to the PB. And in the last 2-3 years, we have diversified into the EPC sector, engineering, procurement, and construction. So we are doing now a number of projects with the civil as well as steel. During the process, we have handled some very complex projects, and I felt it on my part that I should share my experiences onto how we have delivered and how we have utilized the technology to this effect. I have enumerated some factors which helps us to improve the speed and delivery in this. One is 3D BIM model. Earlier, we used to go with two-dimensional drawings, and these days we have totally switched over from two-dimensional to all 3D modeling. And how 3D modeling has helped us, I'll just share with you. Fabrication drawings plays a very important role in execution because a lot of errors does come from this particular source. So what changes we have brought into here? Material planning is another very important area which people do ignore, but it's a very, very vital area, particularly when we are doing multiple projects. At a time, more than 40, 50 projects are going across, and you have to do the material planning. So you have to have a very concrete solution to handle the material planning. Project planning, of course, it is an important factor to deliver any project timely. Billing. I have specifically taken the billing part here because without proper funds flow, any large project you cannot take with it. And normally we have seen there are errors in the billing and you are not able to place billing in time. So we have automated the whole billing process linked with the direction to smoothen that process. Coordination among departments. So there are so many different departments when you are handling a complex project. There are so many different product departments, how you are coordinating between them. Then information sharing is another very vital area, that how you are sharing the information. So how we are sharing, I'll just share with you. And dispute settlement. This is a very, very important area. We have been handling BHEL project of power grid at Agra. At one time, there is a strike by the laborers. At other time, there is a strike by crane people. And how those disputes basically does affect your project, and how we have to handle the settlement of those disputes to take up the projects in a better way. I just enumerated, I asked my designer, a detailer, and put some questions to him. Okay, tell me what are the disadvantages you feel in 2D. And when discussed, I just noted down those points here. A lot of checking time is required to check these drawings when we are working in two-dimensional drawings. It takes much longer time for complex structures. If you have a complex structures, it takes much longer. Assembly drawings are quite difficult and error-prone in two dimensions, particularly when you are having multiple drawings and the connections are coming. So at that particular point, we have the issues. Clash check, which is quite easily possible in 3D model, is not available in two dimensionals. Connection errors is quite, as one of the speakers also pointed out, that in SWORD, when they brought it there, so they faced the connection error issues. So normally those errors are seen at the execution stage. But the main source lies with the technology there which you are using. Complex shapes of buildings are prone to errors. We have seen at number of times, we have designed a simple building, but the anchor boards are not in line. And we have to adjust based on those anchor boards, the dimensions of our rafters. And if that thing is happening and you are doing manually, that's where the complexity comes, and there are the issues which we have. Work on drawings can start only when all issues are resolved. Normally in two-dimensionals, unless until all the issues are resolved, we are not able to start work. Whereas when we are working in a three-dimensional model, this is not the restriction. Now, compared to these two-dimensionals, advantages what we have gained in a three-dimensional is improved visualization using 3D model has made connections, etc., much simpler. Number of times, the senior people, designers, are just standing across the model, debating and giving the solutions. So that's possible with 3D. On two-dimensional, your visualization is much lower. 0% chance of connection errors. I'm saying 0%. That's what our practical experience it has brought us. Phase-wise planning is possible using 3D model. This is another very important aspect. For a large project, you always have to divide into the phases. Best of the people we put for the phase-wise planning. Based on that phase-wise planning, we delivered also at site, but then from site we are receiving complaints, okay, sir, this part is missing, this part is missing. And ultimately the source was lying into that particular part was not planned in the phase, which was needed there in the phase. So using this 3D, we are able to do phase-wise planning in an error-free manner. Multiple team members are able to work simultaneously on one model. In two dimensions, at times distributing among the members may cause a lot of problem. But here, with the complex projects, simultaneously one is doing the column work, other is doing the rafter work, and in the same one model we are able to work. Average experienced detailers can also produce high quality results. In a complex project, you need very highly experienced detailers to do the work, but whereas in the 3D model, even if you have a detailer who is not so experienced, we are able to get very high results from that. It is more cost effective. Maybe you might be feeling, but it is my personal experience, we have saved money using 3D. It is much easier to maintain standardization. For any company, you have to adopt certain standardizations in terms of connections and so many things. So while adopting 3D, it helps us in maintaining those standardizations. I've enumerated some of the limitations in 2D fabrication drawings. It takes longer compared to the working in 3D. A project like Power Grid, where we have almost 5,000 tons of steel, even in 3D, it used to take more than 2 months' time. So with those kind of projects, in two dimensions, you could take much longer. Experienced checkers are required for checking, and it requires a lot of project time. BOM and BOQ are prepared using Excel sheets taking input from multiple sources prone to errors. For any execution, you have to prepare bill of materials and BOQ. So normally when you are doing on 2D, that work is primarily done using your Excel sheets, and that's where the error happens. And that error is at times causing you a tremendous amount of delay in the projects. So with 3D, we are able to take care that we are able to generate BOM and BOQ at a click of button. Multiple expertise among detailers is required to handle a complex structure. There are different kinds of detailing exercises, so you require all different kinds of detailing experiences. In 3D, we are able to avoid that. Phase-wise planning is prone to errors, normally observed slippages in planning at the time of execution, I already pointed out. Highly experienced detailers are required to handle complex structures. Advantage of generating fabrication drawings from 3D model. One model is ready, generation of BOM and BOQ is just a click. So even what we have done is, we have generated model even when there are connections which are not clear to us. So what we have done is, if we have written a letter of intent, we just simply go and prepare the model. And as soon as the things are clarified, those changes are brought into the model, and we can immediately release for further working on it. Connection errors among members are eliminated completely. Overall errors level is much reduced. Checking required is much less. It takes less than 50% time compared to 2D detailing. That's our observation. what we have found is we have saving more than 50% time. Even today, not only the complex, simple projects also, we are taking on Tekla or 3D modeling. We are able to focus on engineering aspects compared to imagination. In 2D, a lot of time we spend on imagining how it will look like, how it will go, but here we are purely able to focus more on the engineering aspects. Now, one is 3D modeling, which we have covered. Now there is another platform which we have built in our organization, that is our own ERP system, which we call it Steel to Build. How that has helped us. Richa is using Steel to Build as business management tool and not merely as an ERP. We have developed this as a complete business management tool. One is material planning. Raw materials have to be procured along with progress of project. One-time purchase results into higher inventory cost. In the past, we have in some of our projects purchased raw materials in one go. We bought the materials are lying, then my customer is saying, sorry, you have to delay the deliveries. And we are sitting on the inventory for 6 months or 8 months because my customer is not taking the delivery, and that is affecting my cost. So basically, what is required is you have to get the materials as per your delivery schedules, as per your, so it cannot be that all the materials you can just buy at one go. Doing it is much easier, but then managing the material flow in between the project, when it is a complex project, is a challenge. So how that challenge we have handled through our ERP system. There is a need to review actual versus planned consumption, and any errors in planning need to be corrected midway. Old material planning system results into surplus materials at the end of project. Normally, this has been a common problem with steel manufacturers. They complete the projects and they are left out with tremendous amount of inventory. And that basically inventory is coming through all the kind of systems which we have. Some materials are received much before others, resulting into inventory pileups. This is another problem of our material planning. You have received some materials, but some other critical materials are pending, and you are not able to ship out your goods. We need to have advanced system for just in time. We need to reduce inventory cost. Material shortages need to be tracked much in advance before these affect project deliveries. So these are basically issues which we come across in our material planning. In North India, material lead time is normally around 1 month, so advanced material planning is vital for timely delivery of projects. When we are ordering plates or anything normally from the mill, it takes around more than 30 days time. So that lead time, in case you have not planned the things properly, it can affect your project deliveries. We have integrated this material planning in our ERP system. Changes in material planning is tracked and taken care at all levels along with alerts. So as soon as, firstly, we have integrated our ERP system with 3D modeling and MBS. So whatever material planning is done, it is directly imported into the system. And as and when there are any kind of changes which have occurred in that material planning, those are ultimately immediately sent alerts to the concerned people. Approvals at different levels for BOM, indents, POs, and MRLs help in minimizing errors. Order quantity versus BOM quantity comparison helps in smooth working with lower inventories. Tracking of indents in PO. This is again a very vital aspect. Plant has indented, okay, such and such material is required, but then a complete tracking of it, how much POs are raised, and a transparency along the whole organization. Rejections, if any, are accounted in the integrated system. So maybe you have received the material and those are getting rejected, so how we have to account for it. Extra consumption of material is accounted without affecting other jobs. At times you have planned for 10 tons and actual consumption might be 12 tons in particular job. So that might be affecting the other jobs, so that need to be accounted for. If required, raw materials can be booked taking advantage of price fluctuations in market. So many times market fluctuations are there, and as an owner, I might be requiring, okay, I want to book 500 tons of steel, but then what is that steel which I have to book? So I need immediate information. So this integrated planning helped us to immediately at a click of button know what all materials will be required in our future jobs. And if required, we can book that. Helps in payment planning depending on different payment terms. Job-wise monitoring of raw materials and consumables. This is one of the sheets which is showing the raw material planning. So here we have grouped them into different groups, like plates 350 grade, plate 250 grade. So at a click of button, all these raw materials which are there in inventory are getting loaded up. Then we have these months here. Jobs which are planned for those particular months will be loaded up. Here we have GA approval. In case we wanted that only those jobs to be considered which are duly approved, so can be considered here. And then here, for each job, we are able to see what is the planning, how much has been actually issued, and how much is the balance there to yet to be issued. At the bottom of it, we are able to track complete state of it. Right now, it is showing the stock here. At the bottom of it, what are the POs which are pending to be delivered. This is total for these two. And then at the bottom, it shows how much is the material which is required in your planning. So this, at a click of button, integrating all departments helps us in our better material planning. For project planning, we are using two basic modules. One is Steel to Build, and other is Smartsheet. Maybe it is a general software for Gantt chart, but we have tried and we found it very useful. Smartsheet is cloud-based, which gives Gantt charts, sends alerts, sends and receive updates, collaboration tool among team members, keeps attachments and works like an Excel sheet. We found it very cost-effective compared to MS projects and other things because it comes with the much lower cost. Steel to Build shows the progress of project. Basically, among the two, what we have done is Steel to Build we are using for our PEB projects, and Smartsheet we are mainly using for our EPC project, for civil construction and all those things. Steel to Build shows the progress of project based on daily inputs from site, helps in payment to erectors which are linked with contractors and work progress. So here we have developed modules where the payment to our erectors are also linked with the progress of the projected site, and it is regularly monitored there. Site progress is recorded using the photographs. Key milestones photographs are separately recorded for reference. On a regular basis, the photographs are coming from the sites, and those are getting recorded into the ERP. And from there, at any moment, any person is able to know the exact status of the project. Daily updates are recorded in the system. Job-wise summary of these updates gives clear glimpse of the project progress. Steel to Build tracks each BOQ component. It gives the date-wise status of shearing, H-beam, fit-up, welding, finishing, painting, storage, dispatch handover along the storage location is also marked in the system. We developed this system primarily, basically, what we noticed was my production department says that they have completed their production. The dispatch department says that they have not received this material. And somehow urgency, we all then you say, okay, fabricate the new one and new part is dispatched, and later on we are finding that part is lying in the factory. So complete tracking for smooth execution is a very essential, and that's where we are able to have the complete status of any component, at what status it is, and this monitoring is able to shorten the overall production time to a very fast level. System shows number of BOQ items produced, dispatched, and balanced quantity. So there is another report which shows what is the status of a particular project, how many are items which are produced and how many are. Production is recorded along with team name who produced it. Team performance graphs helps in preparing any kind of bonuses and identify efficiency. This seems to be a very simple thing. While recording the production, we are simply recording at that level who is the team who has done the production. But with this small information, we are able to generate complete team information. So even we are able to know which fitter team has done how much production in particular month or a particular period compared to other fitter teams or to the welders. And we have designed bonuses system based on this, so that based on those bonuses, we are able to improve the productivity. And your input is hardly there anything. Input is simply the production, but you are registering it. Sequence dispatches are achieved through control and production based on phase-wise planning from Tekla or MBS. So whatever phase-wise planning we have received, that we are inputting here, and then we are able to generate complete reports in our system, what all things are pending as far as phase-wise planning is concerned. Steel to build gives complete data as to what all components are made and which all are pending. These are some screenshots which I have taken. This is basically showing the online production status, particular job number. And here we are able to see out of the total quantity which we have to produce, how much has been shearing done, what is the H-beam done, what is the fit up, and what is the shing, and complete we are able to see. And we are able to prioritize jobs here. So based upon here, what priority we have given, plant has to take things in production. This is a screenshot from Smartsheet, where project scheduling is taking place. This is also a very, very useful tool. I would like people to use it. And it is much, say, better than MS Project, I will say, because here what we are able to do is, firstly, we are able to work on cloud. So all your team members are able to access this. That's number one. Number two, we are able to define alerts here. So here, if you see here, so you can define the alerts, and based on that, to any user, those alerts are sent. You can keep the attachments here itself. So all your drawings or anything which are to be referred in that projects can be kept. Then updates can be sent from here. And I felt it's highly secured. And along with Excel sheets, you can just convert the mode, whether you want to go in Gantt chart or in Excel sheet. So it is an important tool for project management, which I found. This is basically a screenshot from phase-wise, where we have dispatch planned, dispatch 1, 2, 3, and it gives the complete report there. Sequential stacking of material. In the plant itself, when the material is getting stored, so when you have multiple jobs and a complex projects, you need to track down where your material is stored, so that in dispatching, you are not delaying upon the things. Because in the past, what we noticed was the whole shipment is sent, but 2 parts are missing in it. Why those 2 parts were missing? Because my team, dispatch team, was not able to locate those 2 pieces. And those 2 pieces used to affect the project execution. To avoid those things, this thing we built upon. This is some photographs of the stacking we are doing in the plant. This is a screenshot from our ERP for centralized. It gives a complete project action status. So like this, we have, for any PB building, we have planned like this, where this information comes directly from the order itself. And then here we are able to upload the photographs. And here there is a complete architecture behind it. It calculates and gives us the complete status, what is the percentage of the building which we have completed. Discrepancy is another thing which is very vital. At times, there is always some discrepancy. And that we log in here and debate it in the company, who has been responsible, what are the remedies to it. So this also helps in that. Erection linked with billing. Daily erection status is linked with online billing. So whatever material we have dispatched, that is made available to at the site, and people simply has to take, okay, these are the pieces they have erected, and we are able to calculate from that based on what is the pending billing to the client. As soon as the billing is done, that is taken out. So all kinds of errors, we are able to take care of it. And the problem, there was one person dedicated for billing, was not required once we did this. And it has worked flawlessly, particularly in the billing side of it. Clients have taken lesser time in clearing these bills. We built the reputation based on this, And ultimately, we felt earlier when clients used to hold down our bills for 7 days or 5 days to clear, after this system, they hardly took any time because they know that there could not be any error in the system, so they simply cleared it. And it really helped in our funds flow improvement. And again, loss due to faulty billing. When I introduced this system, I could find there are a lot of bills which otherwise my people were saying all we have cleared. But when I introduced, I found there are a lot many things which were still pending to be billed, and we could take care of it. No separate person is required to do invoicing. There's just a screenshot from that. There's some shots from my plant. We are using plasma cutting. CNC parts are generated. CNC parts are generated from Tekla and MBS both, and those files are imported. And those files, once imported, we are taking directly for the CNC cutting over there. We are not doing any kind of manual working for the CNC working. H-beam, we have got 3 continuous H-beam welding lines, CNC punching machine, the cold form profiling machine. This is one of the structures which we recently completed is a power grid GIS switch. These are 2 halls having 5,000 tons, metric ton of heavy structure. We almost completed these 2 poles in less than a year, whereas prior to this, 1 pole took more than 3 years and more than 3 PB companies in between. And this tender also we got after cancellation. And still the 4th one, which was to be completed, is still running on. It has yet to be completed because some other company is taking up that. This is another 46-meter high multi-story building we did at Haridwar. This we did at Lucknow Metro, complete curve. And we have used not sheets, but PU panels on top of it in curvature. Normally, PU panels, it is not possible to produce them in curvature. But here we use the technology, and we are able to give that in. This whole LMRC project depot we had an order where we had to complete in less than 5 months, and we did it much before it. This is our own head office, where we have created G+5 building. It's again in complete steel building. Thank you.